Good evening once again. Welcome to the session. We will be continuing our discussions with the data basis for the analytics. If you take the tour to the sessions that we have conducted on the YouTube Live here on the channel, if I scroll down and click on YouTube link here, it redirects to this page. If I take to the tour to all the sessions that we have recently conducted, right, these are all the sessions. Now, if I say home, these are the playlists that you can see. Okay. What we have done of late is we've been conducting these live sessions to ensure that we impart the knowledge onto, especially to the student community. So if you look at this videos, right, this is one of the videos that we have recently conducted, where our programming for analytics is coming into the picture. Then business analytics, and currently we are looking into the data sources, the databases, because ultimately you need data to perform analytics and extract information. We can also perform analytics using Excel, right? And we also have some of the automated capabilities in the softwares that also are discussed here for data manipulation. Okay, these are some of the videos that you have readily available here. You might want to go through. Now, we discussed yesterday in our first session with respect to databases of analytics, we discussed about the overview of what is analytics, how it is shaping up the business to yield better returns. Right? It's trying basically all the management basically uses the data for taking appropriate business decisions. Right? It's transforming how the businesses are basically being operated. And we have also talked about how technology has played a very, very important role in shaping up the industries, all the industries. And industries also have understood the impact of the technology in day-to-day operations. And when we talk about digitalization, digital platforms, then we are basically trying to record all the incidents that are happening, all the transactions that are happening on a day-to-day basis. Now, this digital imprint of the events is nothing but data. And if you want to look into the past, we have to look into the data, but we cannot keep everything in our brains. We cannot remember as business owners all the transactions that are happening on day-to-day basis. Hence, we try to record the data in a digital form. But if we record it, then while we are trying to retrieve the information, it becomes very chaotic if you're not recording the data in an organized manner. Right? That is where we had this database softwares originated. Right? That's the history, basically, how or what is the purpose of databases. We've also talked about how ETL is basically playing a crucial role in the architecture of entire system architecture for analytics implementation. ETL basically stands for extract, transform, load. Right? Extract, transform, and we say load. So we are extracting the data from many sources, but data that is coming in from these different sources will have different formats, different characteristics. So we are trying to manipulate it through to bring it into a specific format. And then finally, we will have load option where the data is getting loaded into a persistent or consistent repository. This is the ETL task, or we also call it as ETL pipeline because it's kind of automating. Every time new data is coming in, it flows through the same sequence of steps. Hence, we call it as a pipeline. This is what we have discussed yesterday. Data sources, right? And this is the data pipeline where we will have source and destination. And this is the overview of a ETL pipeline that you can imagine, where the data is coming from multiple sources. The data goes into the transformations because it's in its raw format. We'll have to manipulate it. And after that, we'll get the data coming into the destinations here, right? And we'll have consumers consuming the data from this persistent or repository, data repository for their respective purposes. Now, in this entire framework, you can see the three stages, very important phases or stages: data sources, data transformations, and data destinations. And we are talking about the sources. There are different types of sources, but our discussion here is the most popular source, even that is used today, which is the databases. We also have other options. So database softwares remain the most common data sources even today. We also have to understand certain properties of the software that we are going to try and use. We discussed about different data models: hierarchical model, network model, right? Relationship model. The most popular one is the relationship model, the data models that we talk about. We also call it as ER model, entity relationship model. Okay, this is the mind map. You can navigate to 360DigiTMG website. There in the learning resources, you will have this mind map. If I have to go through the sequence of steps, you can see this is the 360DigiTMG website. Here you will have learning resources. If I click on learning resources, or shortcut is mind map, here it is given. Under the learning resources, we have different other resources also that you can utilize. I'll click on mind map and it redirects me to this page where in the drop down, I'll select the SQL concepts. And this is where I get the SQL programming mind map. So SQL is nothing but a query language. It's basically a medium to communicate with the software. What is the software? It is basically called as DBMS. It's a management system. It's a software which manages the data, the entire data that the organization is trying to record, generate, and of course record. The variant of this is RDBMS. It basically talks about how we are trying to organize the data, right? Based on that, names are given. R stands for relational database management system. All right, and the logic of RDBMS is basically to define relationships between tables. And here we use this terminology: entity is nothing but a table. Attribute is the column of that particular table, which is also called as a feature or characteristic. Right, and when we talk about database softwares, the database softwares can be interacted with some medium, right? That some medium is nothing but SQL. So this is your DBMS. It will always be represented using the cylinder symbol, friends. This is the standard notation. And we try to access whatever the data that is required. We try to access the data using your SQL commands, SQL instructions. We call them as queries. We discussed also about the asset properties that the database softwares have to be maintaining to ensure that there is data integrity maintained. And ACE in ACID, A stands for atomicity. It basically says that the transaction has to be at its most least granular stage, where either you do it or don't do it, right? It cannot be intermediate. And consistency basically talks about the data will be consistent, right? Before the transaction is successfully completed, whatever the values are, those values will be intact. There will be no intermediate values. The transactions, right, should also be isolated. That means the transaction should happen in memory, not impacting the actual data. Until the transaction is completed, it has to be intermediate. It has to be isolated. Then we have durability. Once the data is stored, whatever the changes that you want to do, you make those changes. And once the data is ready, then that data should not get altered. Data is consistent, right? So once you have made some changes to the data, unless until you again use that same data to make any changes, it has to be intact. So this is the overview of our database software. Now, the very, 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 very important logic of the database management systems is how you are going to organize the storage. So it's just very simple, friends. If you are familiar with your computer, in your computer, you'll have a hard disk, right? Storage disk, storage location. Whatever data that we are trying to store is getting stored onto this hard disk only. Whatever you try to store, it has to come ultimately to the hard disk. So we are basically saying, I want to store the data. So it has to come to the database, the hard disk only. But the database software is trying to come here in between. There's an application, right? This is a software which comes in between and says, we will eventually store the data here only. But the logic of the storage is defined here. Right? You're trying to arrange the data in a specific format. You're saying that your data has to be arranged like this. That logic is defined here in the software, DBMS software. So physically, the data will get stored onto the hard disk, but the software is defining how it is getting organized. This is very important. It has to follow certain rules and regulations. Only then accessing the data becomes easier. So when you are storing the data, you will have to ensure that these rules and regulations have to be followed even before the storage is happening. The rules have to be defined. Only then you will be able to store the data using those standards, right? So we will basically talk about storage, but storage also has to happen using these rules and regulations. Only then accessing the data, retrieving the data becomes easy. Data retrieval becomes easy. All right. So that's basically how your database software works. Now this standard that we are using, right? There, as I said, there are rules and regulations. There are certain standards that we will have to follow. And these standards will be defined using the scope of the software. There are certain predefined rules and regulations that are given. Considering those rules and regulations, you will define some standards for your data storage. All right. So these rules and regulations are the way we are trying to organize the data, right? These standards that we are maintaining, that is called as schema. This is nothing but the logic or definition of how your data gets stored. Right? It does not just keep the definition of the format in which the data is getting stored, but it also ensures that it defines what data is getting stored. All right, so this is called as a schema. We call it as a table schema or column schema. But generally, we call it as table schema. It includes columns definition also. So in short, this is nothing but data definition. For example, there is, let's say, an educational institution, your college, for example. In your college, there are a lot of details that have to be recorded. One of the detail is student details. You'll have course details, you have faculty details, you have extracurricular details, you have accounts details, right? So many other details will come into the picture. There are different departments who are maintaining these different data touchpoints, right? So they generate the data. So for the entire organization, whatever the data that is getting generated, it has to be stored in certain physical location. And we are defining a logic and then trying to store the data. This is called as ER model. Entity relationship model. As we discussed, entity is nothing but a table. For example, student table, department table, right? Or accounts table, etc. That's entity which is representing the real world case. Then we have attributes for these entities. These are nothing but columns, as I mentioned, right? So if I talk about student column, I'll have student ID, name, gender, right? Which course they are studying, which year they are studying, right? So on and so forth. Likewise, we will have details for department, details for accounts. These are nothing but column names. Then this is important, the relationship. Now, what happens is when you talk about the database schema, we call it as database schema. This database schema basically explains the entire, I should say, the tables set that this business or university is having. Schema is nothing but definition, right? So it contains how many tables are there, what is the relation between these tables, etc., etc. All right. That's your overall database schema. We call this as ER diagram. So the entity relationship that we are defining is represented in a diagram form. We call it as entity relationship diagram. So this is nothing but entity relationship. To represent it, we represent that in a diagram form. Okay, that's database schema. Then for every table, you will have table schema. Now in the table schema, you will have column names and column definitions. When you say column definition, we're not talking about business perspective, like name means it's not student name. It's not that definition that we are speaking about. The column definition basically is a definition which explains the system, the computer, on what data that this column contains. So we are giving a key word, a header, a name to the column, but to define the meaning to the computer, we will say that this is a string data. This is Boolean data. It can only take male or female. Course ID, or if it is course name, then it is a string. Which year? This would be an integer. Student ID would be an integer, right? So this data type definition for each column is basically comprising, is what is comprising in table schema. This becomes the true definition of a table. Now, how do I define relationship? So I'm saying that each student that we have who's enrolling into the university should be associated with some department, right? I mean, you cannot give, for example, if it is a graduation program, you cannot just add a student to graduation program. They have to be basically taking some specialization branch. It could be computers, it could be mechanical, it could be electronics, right? So on and so forth. So every student has to be attributed to some department. And student will also have to pay the respective fees, right? So in the student table, I will have student demographics. If I go to department table, I'll have department details. If I go to the finance tables, accounting tables, I'll have the student fees and when, how many installments, what is the fees, right? All those details. So we are trying to define the relation between the tables so that when I look into all these three different tables, I will be able to get information which is organized in an appropriate format where redundancy also is not happening and data security is also maintained. So here we will have to use one of the very important word, which is called as redundance. Okay, redundance. Redundance, or in other words, we are basically saying duplication. So we do not need to have any redundancy, or we need to have no dependent, no duplication. If I try to store everything in a single table, you might say that, hey, why do I need to create three different tables for this? Why not have one single table where you contain all these information, right? Entire data. Yes, I can do that. But what is happening here? Look at this. I'll have student ID, right? Student name, fees. And then I'll talk about the department. Okay. Then I'll talk about the department, let's say, department head, HOD, head of the department, right? And then I'll talk about all the faculty that are there in this particular department. Now, how do I capture this information? How do I capture all the faculty that we have in this one department? Let's say computers department. So using a single student, you are the student, assume you have an ID called 123, right? Your name is XYZ. All right. Now, given all this information, let's say you have paid some, right, X amount of money. You are coming from computers department and you are having ABC as your head. But what about the other faculties? I'll have multiple faculties. So in order to fill this up, I'll have to write again the same record. I'll have to write multiple times. So there's a lot of duplication, or I cannot write this faculty details into this particular table. So this is the challenge that we will have. You'll also have to ensure that the duplication does not happen. To maintain this, right, all these different properties that we talk about and data integrity for that matter, we will have to follow that structure or the arrangement that is predefined. Right, so we call it a schema. It is nothing but the structure in which the data is getting stored. It's just like your physical house construction. We want to construct, we want to build a house, right? So what happens? What is the process? Of course, you'll have to buy land first, right? Obviously, we'll have to acquire land. Okay, then after that, I'm talking. If you want to construct a house, first is you get measurements and then planning. The planning happens, right? We also call it as blueprint. Without this blueprint or without the planning, will the construction start? No. So we need to have the first step, planning done. Designing has to happen. Then after that, you don't just jump into constructing immediately after planning. You need to get approval of this constructions, right? You need to get approval of the plan that is given for proceeding further with construction. So once the planning is done, once the approvals are obtained, only then the constructions begins. But that construction also is following the instructions that are given here. It doesn't happen as you wish. It has to follow the rules and regulations. This is how the construction of a house happens. Same way, we are first planning and designing the architecture. We define that, we call it as schema. Okay. Now, once this is done, only then, right, after your management and experts approve of this structure or the plan, a blueprint, only after that the data gets stored into the database. Until then, data will not get stored. Okay. Now, coming to the model, right? I talked about ER model. That is what we are discussing right now. This ER model, or the model that we are traditionally speaking, works when you have data which can be arranged in a two-dimensional format. Because computers understand only x-axis and y-axis. That's all. You don't have third axis in your computer. You might say, I watched 3D movie, but that is not something that is there physically. It is kind of a, I should say, perception that is created for you to see the certain information in certain angles. Okay, so your computer screen or any screen that you talk about is only a 2D screen. That means you will have data arranged in only two directions, right? So that is two dimension. And here we will talk about matrix mathematically, and then we will also have tables. In SQL, we will use this tables because we also want to give the definitions. Matrix cannot be given the definitions appropriately. All right, so tables is the only way. So if your data can be arranged in this two-dimensional format, in a table format, then that data is called as structured data. And the traditional databases that we are talking about, especially if I talk about the legacy systems, the database management systems, the variant that we are speaking about is RDBMS, will work only on structured data. Right? Typically, whatever the examples I'm talking about, like your transactional data or operational data that we are gathering on day-to-day transactions basis, we will be able to have that data stored in table format. Only that data can be used for storing in the legacy systems. The instructions that we basically give are also following certain standards. We call that a structured query language. We write certain queries following the rules and regulations, and we'll try to retrieve the data to manage the database. Okay, so this is a language, a medium to manage our data, to communicate with the data that is getting stored via RDBMS. But what if you have data which cannot be brought into this structured format, two-dimensional format directly? What if you have that kind of data? Examples, I have text documents, text data. I have, let's say, images, or I have audio files. Or finally, I have combination of these two, which is videos. So all these are the data formats which basically do not have the two-dimensional structure. Now, if I have to work with this particular kind of data, because as we speak today, majority of us are generating this unstructured data. It's called as unstructured, semi-structured or unstructured. We will write unstructured data only. It is semi-structured, then it can be structurized, no issues. Right? So we will talk about unstructured data. Now, when you're dealing with unstructured data, you cannot use this legacy systems. You need to organize this data in a different format altogether. There are again different ways to do it. You can put the data in a key and value pair arrangement. You can gather everything as a document and then store, right? Column wise databases are also there. Graph based are there. So there are different ways in order to store the data, right? We also have the new variants of databases coming into the industry, specifically used to perform analytics on large amount of data and unstructured data using this particular database. We call this as vector database. If you have not heard about this, you might want to explore this. This is going to be the future. Vector databases, which are specifically designed to work with unstructured data, which can be embedded into vectors for processing purpose. Hence the name vector database. So unstructured data is getting converted into a one-dimensional structure vector. So that's the logic that is followed in vector databases. But anyways, that is a little advanced for our discussions at this point of time. So we are talking about data which is unstructured, right? And in this case, you will have a different set of tools for organizing the data, and we will be using NoSQL. It's again queries only, but they follows a different standards altogether. We call this as NoSQL for dealing with unstructured data. There are many unstructured data examples in the industry. MongoDB, HBase, Neo4j, Cassandra, right, etc. Repositories there. All those follow different structures for storing the data. All right. So what we are trying to understand is the difference between SQL and NoSQL. So these are the language mediums which are used to communicate with the data that are getting stored in the software. SQL stands for Structured Query Language, language used for relational databases, RDBMS basically. And RDBMS works in data which is organized in this table format. So it basically called as a structure. We have Oracle database, MySQL database, MS SQL Server, we have Postgre, Sybase, etc. On cloud also, we have plethora of solutions available. It's nothing but a table. Okay, and if I have to use this table, then the schema has to be predefined. Only then I'll be able to store the data. Okay, predefined schema or predefined schema means you'll have to define the structure in which the data is getting stored. Right, hence it's called as structured data. Now, NoSQL stands for not only SQL. Right, we basically also call it as non-relational. Here, we basically talk about dealing with data which is in unstructured form. Right, it cannot be arranged in a table format. You cannot define anything for this arrangement because it doesn't follow any specific storage pattern. Right, so we defined certain storage patterns for dealing with these kind of data like column-oriented, document-oriented, graph-based, or you can also say key and value store. So these are the examples of NoSQL databases. HBase, MongoDB, this is very, very popular open source software. We have Bigtable and Redis. These are some of the examples of NoSQL databases, along with your HBase, and then you also have Neo4j, one of the popular databases for image-based storage. Now, if I have to do a quick comparison between SQL and NoSQL, SQL talks about structured data. So it is the legacy system or traditional way to store the data, whereas NoSQL does not have any predefined, it basically can store any kind of data which is organized in any format. So databases, SQL databases have to be following certain rules and arranging the data in an organized fashion. Right? That organized fashion, the arrangement, the model is called as structure or schema. So we will have predefined schema. Here you don't have to follow that. data can be in any format, 3 dimensions, 4 dimensions, right? Like this. So the data becomes unstructured. So we are using a different logic, like defining one entity, one file as one document and storing. We can also have a graph-based representation, hierarchy-wise, we try to store the data. Here, schema is not predefined. It is something that you can define, right? Dynamically, it can be. A SQL table will always be row-oriented. That means you cannot manipulate columns easily, but you can keep adding or deleting rows. Hence, it's called as row-oriented databases. Right? And scaling can happen vertically. Vertically means this vertical axis, you can scale up. That means you can keep adding the data into this table. This limitation is not there for this feature, I should say, is not there for NoSQL databases, because NoSQL databases have different logic. If I use a structured kind of an arrangement, a table kind of an arrangement, even there, the data will focus more on the attributes. It does not focus on the samples. That means attribute is nothing but a column, right? So NoSQL data points will focus more on the features, not on the data that feature is storing. Hence, you can scale horizontally. That means you can keep adding many columns also. All right, so that's the advantage that you have. And there are a bunch of other advantages that you will also see. The SQL, as I was explaining, should follow ACID properties. Okay, this is mandatory. Atomicity, consistency, isolation, and durability. But whereas the NoSQL databases do not follow ACID properties, they use something called as CAP properties, right? They follow this CAP property. CAP basically talks about consistency. C is nothing but consistency. But A does not speak about atomicity. It basically talks about availability. And because we are dealing with unstructured data, which can also be very large, we can also partition data and store. Right? CAP is basically talking about your consistency, availability, and partition. Or you can say partition tolerance. You can split the data and store. It doesn't really matter. All right. So that is the difference between SQL and NoSQL. All right. Next, I also want to talk about one more very important topic here. Okay, that is the destinations. Now, what I was trying to bring in is data sources, and we are talking about databases. But what about the data destinations? Because from a definition perspective, databases are used for archiving, storing, organizing the data, right? I mean, in a specific format, and then storing the data into the system, right? So in this scenario, what should be there in the destination? Where do you put the data? Right? That is also another very important question that you'll have to look at. Ultimately, this is a software which is used to store the data. Here also we are saying load is for loading the data only, right? You want to store the data only. So what is the difference here? Anyone? Anyone? What would be the difference here for the data sources and destinations? Because see, ultimately what is happening is whatever the data that you are getting generated, right? So this is getting generated. We are trying to get the data and store it, right? Accumulate it somewhere. So here also I'm doing the storage only. Here also we are using database softwares to store only, right? So what is the difference here? Let me see if anyone can answer this question. What is the difference between the softwares that we are using here at the source and the difference here that we are using, I mean, the same software that we are using at the destination? because ultimately we are trying to store the data in both the cases. Yeah. No one is able to answer that? So from the software's perspective, you may use same software at the destination and same software at the data source. For example, you can choose any of the RDBMS variants. The most popular open source free software is MySQL. You can also talk about Postgre. Okay, so these are both open sources. Okay, so I can use the same software here, the same software here. I may use, right? I mean, it's ultimately stored the data, right? But the purpose varies. At the data source, the purpose of using the database software is to record all the transactions that are getting the data that is getting generated based on the transactions. So it is used for storing all the transactional data, right? So here we will have live data or the current data, the new data that is constantly getting generated. Those data points are getting accumulated. So here we will have transactions data at the source. But at the destination, what is the purpose? Why we are not using the same transactional data source? We have the same data here also, right? But why I want to move it to destination? The purpose of accumulating the data after cleaning, of course, is to perform study on that particular data. Analytics can be performed, studied can be done, right? Research or study can happen. So the purpose varies, isn't it? This is where you need to understand that the definition of OLTP, sorry, let me write TP first, OLTP versus OLAP. All right, very, very important. OLTP talks about online transaction processing. This is transaction processing. As I said, when the business is generating the data, the live transactions happen. Let's say you are basically a customer, you are interacting with the website of that organization, whatever that is. It could be, let's say, accessing hotel rooms. It could be like accessing movies database. You could probably try to book train or bus tickets. So you'll have some kind of a portal where you'll have all the details available there. That detail will come from the database only because it has the historical data. So for example, you want to travel somewhere and you're booking, right? You want to book some ticket. So what is the current status? How many seats are available? And all that is available in this database. Unless until you know the current state, you cannot book the tickets, right? So what happens? The communication happens here between the front end web page and the database, which is back end. So what is happening is the live transaction is happening, and to support that transaction, this database is being used, which is basically storing all the historical data. Right? So live transactions are happening and this database is supported. Now, if I say, okay, you do your job, I also want to perform analytics here. So I want to get to see how many seats are booked, right? Statistics, I want to perform some statistics. I want to see when the seats are booking, how many seats are booked, at what cost it is booked, right? All that analytics I want to perform. That means you're trying to add burden to the instance, and this data keeps constantly changing, right? So you'll not be able to get a fixed information because it's live transactional data. It's already busy. This database software is already busy supporting the customer. So there's a lot of inconsistency that comes in, right? And overall performance also becomes very weak because you're adding additional load onto the same database. Now, this is basically also, right, giving a problem because you will get inconsistent reports. Let's say you are trying to search for the seats, right? You want to travel, let's say, from Hyderabad to Bangalore. You're looking at different options and you've chosen one bus and you probably want to book a ticket. And you're seeing the current status as book, seat number 10 is available. You're trying to book it. But in a split of a second, there is another customer who has already purchased that ticket, right? So you will not see the same ticket when you are trying to purchase it. So that variation comes in. Okay, so there will be a lot of rules written on this database to ensure that consistency is made. That's why you will not be able to book the same ticket that is right purchased by other people. Okay, so locks and all those things will come into that. Is a different logic altogether. But that's basically right protection, or just to ensure that consistency is maintained, we do that. How do I get reports then? Right? So this is where we create another repository of the same data called as, that repository is called as online analytical processing. Okay, so we basically talk about analytical processing. Now, in this analytical processing, what happens is the entire data is getting dumped here. Right? Now, it is not live. It is basically some data which is at this stage, right? At this very instance, whatever the data that gets moved here. Now, I can take multiple people, or multiple people can access this, and this data is consistent. It's not changing now. Unless until you refresh and push new data into this, the data is consistent here, and whatever reports you are generating will give you consistent information when if you are taking the data at a specific time point. And there is no problem. Many users can access the same data parallelly. Here, you cannot do that. Multiple users cannot access the same data because it is write protected. Right? So this parallel system is specifically designed for doing the analytics. All right. So that is the primary difference on how we are using the softwares. But ultimately, I can use the same database software here and the same database software here also. But of course, because at the destination, you will have lot of data getting archived, stored from different sources, right? You need a more powerful system, a highly scalable software. That is what is called as data warehouses. Okay, we basically look at data warehouses as a large scale database software only. So you can just imagine database is like a smaller version, data warehouse is like a very big version. All the properties of your databases will also hold good in data warehouses. Or we also have something called as the data lakes. Data lakes are even, I should say, cost effective, much less in expenses, right? And it can also hold even larger data that your data warehouses may not store. Okay, so these are the two different destinations that you can see, the data lakes and data warehouses. You can see in that image also, it's given here, data lakes or data warehouses. Right, so we basically use these softwares to store. If I have to just explain, this is like a very, very large, high-scale database software, and this is like your disk storage space. If you want to imagine, this is a very simple way to explain data lake and data warehouse. This is about destinations. Again, coming back to the databases. Now, what is the structure and how do we ensure that the structure is maintained while the data is also getting stored? As I mentioned, right, the schema has to be defined first. So step number one, when you are trying to organize and store your data in the databases, the step number one is design your entire DB. Design the DB. This is nothing but come up with ER model. You can explain in an ER diagram also. It's like a flowchart that you will see, right? Relationship between multiple tables and all that. This is step number one. Then you start defining the structure. After you plan, you first define the tables. This is where your schema brings in data. When you're defining you have to give the definition of it, right? Schema has to be defined. And then comes this storage part. Load or store the data. So unless you define the structure, you cannot start the construction of your house. Same way, until you have a defined table, you will not be able to store the data into the database. All right. So this is the flow. This is mandatory. This is how it works. Without the definition, you cannot store the data. This is how it ensures, right? The logic will ensure that the data is always stored in an organized fashion. And that is the reason why I said schema is mandatory in the SQL databases. It has to have predefined schema. For NoSQL, that is not required. You can dynamically define the right way or the logic in which you want to store the data. Now, when we talk about a software, right? When we talk about a software, this software is used for managing your data. And when I say management of the data, there will be different type of roles and responsibilities, right? Different types of, I should say, operations that we should be performing in order to manage. These different stages can be categorized into admin activities, or I should say super admin activities, right? Then admin activities, and then an end user activity. User activity, right? It's not an admin, right? It's just a regular user. Super admin, of course, will be the root, right? And the super admin will give the permissions to perform administrative activities. Administrative users will have different kind of powers. Now, when we talk about data, the data loading can happen, update can happen, deletion can happen, right? All these admin activities, all these kind of activities can be defined by, performed by admin. In fact, you're defining the schema also can happen here. All right. End user can only read. Okay. They can only do read operations. They cannot do any write operations or update operations. So from the privileges perspective, you can give certain permissions to end users also. So here, the activities that we talk about can be categorized as read, write, and update operations, right? Read, write, or update operations. Update or modify operations. Okay, these are the three types of activities that we can perform. All right. So the roles and responsibilities and the activities can be categorized like this. So the kind of operations that we can perform on the software that is your database management system, are categorized into different types of commands, instructions. These commands are broadly categorized into 5 types. And these kind of, all the instructions or all the operations that we can perform are based on certain instructions that we are giving to the software, right? And those instructions should follow these standards, SQL standards. It's a language, so it follows certain syntax, right? Like in English, we follow certain standards, like words have to be used in this way, meaning of this word, the pronunciation has to be like this, the grammar is defined, right? So there are some rules and regulations when you are trying to communicate in English. Likewise, when you're trying to communicate with the database software, you will have to follow certain standards. Those standards are called as SQL. Now, using these standards, we can categorize our entire operations that we are performing into 5 types. All right. Now, these are the operations that we will have to focus on. And as an end user, you would be focusing on DQL, stands for Data Query Language. This is where you'll only be performing read or retrieve operations. All right. And this is where you'll have to focus heavily. But the other things are more from an administrative privileges perspective. Right. And we will be discussing about these 5 data definition languages. These 5 types of commands, starting from data definition language to data query language. What does each of these, right, the standards or these 5 options that we have in SQL are capable to allow us to perform? This would be the topic tomorrow. So as part of today, we discussed about the difference between SQL versus NoSQL. We discussed about OLTP versus OLAP. Importantly, these are the things that we discussed about. And we have also tried to look at the ER model, which basically is nothing but schema, SCHEMA. We try to understand these 3 things at a high level as part of today's discussion. Tomorrow's discussion will be SQL commands. Now, all this information is available here in the mind map, friends. All you have to do is come to the SQL mind map, and then you can see, right? This is the data definition language. Then we have data manipulation language. Then we have data control language, transaction control language, and DQL, data query language. Each of this 5 different stages of commands that we are looking at have a predefined set of instructions or commands that we can use. So we will break down those things tomorrow, and we'll continue our journey in understanding the SQL in a very simple and very interesting and enjoyable manner. So we'll continue our discussion tomorrow. Hope you have enjoyed today's session and learned something new. With this, I'll stop for the day, and please mark your attendance that is giving in your chat message. Right. So thank you so much, friends. I'll see you all tomorrow. Good evening.